Let your breathing slow. There is nothing you need to understand immediately. Tonight is not about memorizing facts. It's about gently expanding your sense of scale. We begin here, on Earth, a planet that feels immense when you stand on its surface. Mountains rise for kilometers. Oceans stretch farther than the eye can see. The sky appears endless. For most of human history, this was the entire universe. Everything above was mystery. Everything below was home. But as technology allowed us to step back, first into the sky, then into space, something extraordinary happened. The universe didn't just get bigger. Our definition of big began to fall apart. From orbit, Earth becomes a sphere just over 12,000 kilometers wide, wrapped in a paper-thin layer of atmosphere. That delicate blue edge contains all breathable air, all weather, all life that has ever existed. From here, Earth already feels small. As we pull farther away, the moon fades into darkness. The sun grows brighter for a moment, then shrinks into a distant star. The solar system reveals itself, a flat, orderly disk of planets, debris, and frozen remnants stretching billions of kilometers outward. Light takes hours to cross it. Gravity still feels dominant here, familiar. Then we pass its edge. Beyond the Oort cloud, the sun's influence weakens. Stars surround us in every direction. We are now inside the Milky Way galaxy, a structure so vast that light needs 100,000 years just to travel from one side to the other. The Milky Way contains hundreds of billions of stars. Many are older than the Earth. Some are already dead. Around many of them, planets orbit quietly, unseen. From inside the galaxy, it feels infinite. But from a distance, it becomes clear that it is only one island of light in a much larger ocean. Galaxies are not alone. Gravity pulls them together into clusters, enormous assemblies of hundreds or thousands of galaxies, all moving together through space. These clusters are among the most massive bound structures known. They contain vast clouds of superheated gas, invisible dark matter halos, and gravitational forces strong enough to bend light itself. And still, this is not the end. Clusters connect to other clusters. They stretch into long chains and flattened sheets known as superclusters, spanning hundreds of millions of light years. At this scale, galaxies are no longer visible as individual objects. They are points, statistics, patterns. This is where astronomers began to notice something deeply important. The universe is not evenly filled. Matter gathers along enormous filaments, leaving behind immense voids and regions of near-empty space so large that entire galaxy clusters could drift inside them, without ever encountering another structure. Together, these filaments and voids form what we now call the cosmic web. From far enough away, the universe resembles a vast, three-dimensional network, like threads of light woven across darkness. Along these threads, galaxies form and evolve. Between them, space stretches almost completely empty. At this point, the idea of an object begins to lose meaning. These structures are not solid. They do not have clear edges. They are shaped by gravity acting over billions of years, guided by dark matter we cannot see but whose influence dominates everything. And within this cosmic web, scientists discovered something that challenged one of the core assumptions of modern cosmology. A structure so vast that it approaches the size of the observable universe itself, the Hercules Borealis Great Wall. Despite its dramatic name, this structure cannot be photographed. There is no image that can capture it whole. It was discovered indirectly, through the distribution of gamma-ray bursts, some of the most energetic events ever observed. These brief flashes, originating in distant galaxies, appeared clustered across a region of space far larger than expected. When astronomers mapped these events, a pattern emerged, a colossal region, stretching more than 10 billion light-years across. To put that into perspective gently, the universe itself is about 13.8 billion years old. Light crossing this structure would need nearly the entire lifetime of the cosmos. This raised difficult questions. According to the cosmological principle, the universe should appear smooth and uniform when viewed at large enough scales. Structures should average out. No single region should dominate. And yet here was something that seemed to. Whether the Great Wall is a single coherent structure or a statistical alignment is still debated. And that uncertainty matters. Science does not chase certainty. It earns it slowly. What remains clear is that matter in the universe organizes itself on scales far larger than we once believed possible. At these distances, our language breaks down. Largest becomes less meaningful. Object becomes questionable. The universe stops behaving like a collection of things and starts behaving like a continuous system, evolving, expanding, connected. As we zoom out even farther, the Great Wall itself fades into the cosmic web. The web dissolves into faint temperature differences in the cosmic microwave background, the afterglow of the Big Bang. Beyond that, there is nothing more we can see. We have reached the edge of observation, and in this quiet place, something unexpected happens. Instead of feeling insignificant, many people feel calm, because when placed against the vastness of the universe, worries lose their sharpness. Time slows, perspective widens. Earth does not disappear, and it becomes precious, a small, fragile world capable of thought, a brief spark of awareness inside something unimaginably vast. If journeys like this help you feel grounded, if cosmic perspective brings you peace rather than fear, then subscribing to this channel simply means choosing to return to this feeling whenever you need. A quiet reminder of scale, humility, and wonder. The universe is not rushing. It has all the time there is. And for now, so do you.